Hey everyone, this is the recap video for the March 30th 6B Algebra class at MTRW. So as I mentioned in class, I won't be recording Zoom, but I'll be leaving these recap videos that are a bit shorter, that review kind of what we did that day in the lesson. So today it might be a little on the shorter end because a lot of the lesson was spent figuring out how to use Zoom, but regardless, we'll go over everything we did. So the first thing we talked about, besides announcements and plans for the class, is we talked about homework questions. So the first question came from worksheet 153 to 155. This is the question where we had a lot of expressions with lots of parentheses and we had to distribute signs. I'm only going to go over part D. So now's a good time to flip to this page in your workbook. The question wants us to get rid of the parentheses in this expression. And when they say get rid of the parentheses, they don't mean simplifying things inside first. They want us to distribute the minus signs. So the first minus sign I'm going to deal with is actually going to be the innermost one, which is here. And remember that when we distribute the minus sign, we have to flip the sign of every single term inside here. Maybe I should have circled it more like this. This is a very common mistake. So we have 18.6 minus 5.7. Now we have to flip all the signs. So positive 13.7 now becomes minus 13.7. Minus 3.6 now becomes plus 3.6, and so on. Minus 1. And we have one more layer of parentheses, so we got to do this one more time. This time we have 4 terms to distribute to, so we got to be careful, keep track of all of our signs. Right? And now at this point, you might be asking, what was the point of all of that? Why couldn't we just simplify things in the parentheses first? Well, it turns out that these numbers are quite nice. They play well with each other. We have a 0.6 over here and a 0.6 over here that is being subtracted. And we also have a 0.7 over here and another 0.7 that's being subtracted. So why don't we regroup our terms? So we have 18.6 minus 3.6 plus, I'll now bring in the 13.7 minus 5.7. And then we leave the 1. So this line, it uses the commutative property because, running out of space. Commutative property. Because we changed the order of these terms. Like we, for instance, moved 3.6 up to the front. But we also use the associative property. We use the associative property because we're saying we have to group these terms together. Usually I would just add from left to right. But this is saying, hey, I want to add these 2 terms first and then add these 2 terms. And you don't want to just go one after the other. All right, this is great news for us because this is an easy subtraction. The 0.6's go away, and we're just going to get 15. And same deal here. The 0.7's go away, and we're just going to get 8. So 5 plus 8 plus 1 equals 24. So actually, in this case, getting rid of the parentheses by distributing the sign, it gave us these really convenient terms that we can cancel out. And it helped us, it makes us less likely to make mistakes if we're only working with whole numbers at the end than if we're working with decimals. Okay, cool. So the next homework question that we went over was from worksheet 156, or workbook 156, sorry. Number 3. So I think this one tripped up a lot of folks because the signs get really tricky. We have minus x's floating around. We have some numbers that we're adding, some numbers that we're subtracting, negative numbers back and forth. We'll just go over part A because the rest of them will look the same. And there are going to be two methods that you can use to tackle this, and both methods are equally good. If you just have a personal preference of which one you're less likely to make mistakes in, go with that one. So method one, the idea is you first solve for minus x. So pretend that minus x is a variable. Okay, so if I now pretend that minus x is my variable, this guy, I'm almost done solving for it. I mean, I just have to subtract 13.5 from both sides. So I have minus x is equal to 21.8 minus 13.5. If we do the subtraction, we get 8.3. Now, if minus x is 8.3, then x has to be the opposite of 8.3, which is minus 8.3. All right, so that's one way where you block off minus x. Solve for it first, and then just flip a sign at the very end. There's another way that's just as good. I call this the move more stuff around way. So if the minus x, like the minus sign in front of the x is bothering you, then why don't we just add x to both sides first? Get rid of the minus x. If we add x to both sides, then we have 13.5 is equal to 21.8 plus x. Now we just need to isolate this guy, so we can subtract 21.8 from both. And then we have x is equal to minus 21.8 plus 13.5. In this case, we're adding two numbers with a different sign. So we first actually want to take their difference, the difference in their absolute values. This is 8.3, and we want to keep the minus sign. So now we have, I'll just write it over here, x is equal to minus 8.3. Cool. Next, we're going to go over this worksheet. I think if you want to follow along as if we were doing this in class, every time before I go over a question, take a couple minutes and try it on your own. All right, I'm trying out this rotated screen instead of the long one. Hopefully you guys can see better. So as a fun application of all these negative numbers and rational numbers that we're adding and subtracting, let's talk about how we measure temperature. So in the United States, we use Fahrenheit. This is what we're used to. We're used to saying, 90 degrees is hot, 40 degrees is cold, so on. But literally the entire rest of the world will use Celsius. So I got some questions during class about what scientists use. So scientists do use Celsius quite a bit. That's because it has really convenient measurements for quantities related to water. So for instance, the freezing point of water is basically 0 Celsius. So that's the temperature where water turns into ice. And the boiling point of water is 100. So that's when, let's say you're boiling a pot of water, that's when you start seeing steam at 100 degrees Celsius. Scientists also use something called Kelvin. So I'll just make a note of that on the side. And that's helpful because the lowest temperature possible in this theoretically is called absolute zero, and that corresponds to exactly 0 Kelvin. Turns out that Kelvin and Celsius are actually really similar. They're just off by some additive factor. So that means you can add a number to go between Celsius and Kelvin, or subtract and vice versa. Okay, so for this worksheet, we start out by getting a formula for converting temperatures in Fahrenheit to temperatures in Celsius. Actually, the reverse. It's much easier to use this formula if we know C, because we can get F just by simplifying an expression. So this is saying if we know the Celsius temperature, we can get the Fahrenheit temperature. Okay? So the first question is, what is 60 degrees Celsius in Fahrenheit? So in this case, C is equal to positive 60. We have F is equal to 9 over 5 times positive 60 plus 32. So this 9 over 5, there are a couple of ways to deal with this. We can either multiply 60 and 9, or we can divide 60 and 5. I think in this case, let's cancel out 60 and 5. We get 12. 9 times 12 in this case is 108 plus 32. And this will get us positive 140 degrees Celsius. Oops, Fahrenheit. My bad. That could have been very wrong. Now let's consider C is equal to minus 60. So this is some practice with my negative numbers. Now we have 9 over 5 times minus 60 plus 32. So we deal with the minus sign in a really similar way with addition, but not quite. Here we just have to check if the two factors have the same sign. If they have the same sign, then the product will be positive. If one of them, though, exactly one of them has a minus sign, then the product will be negative. So we can still cancel out factors here. And now instead we're going to get minus 108 plus 32. And if you do the math, this becomes minus 76 degrees Fahrenheit. Cool. Now let's talk about water. So this question 2, it's asking to translate 0 and 100 into Fahrenheit. Question 2 is really asking the same exact thing as question 1. We're going to do the same calculations, but just with different numbers plugged in. I just wanted to emphasize the 0 and 100 because these are really easy numbers to work with and important quantities for us because of how they're related to water. So in this case, first one, C equals 0. F is going to be 9 over 5 times 0 plus 32. I love multiplying by 0. Everything just goes away. So we get 32 degrees Fahrenheit. So when you walk out in the winter and someone tells you, hey, it's 31 degrees right now, you know that's below freezing. Similarly, if C is 100, in this case, then F is going to be 9 over 5 times 100 plus 32. So I'm actually going to cancel out the 100 and the 5. I always usually try to cancel because you end up working with smaller numbers in the numerator, and you're less likely to make mistakes with smaller numbers. So 9 times 20, that's 180 plus 32. And you do that, and you get 212 degrees Fahrenheit. Nice. So really, again, question 2 and question 1, the calculations were no different. If anything, they might have even been easier for question 2. Cool. So question 3 is now asking, we want a formula for C in terms of F. We originally got a formula for F in terms of C. So now we want to start with this F equation. F equals 9 over 5 times C plus 32, and solve for C in terms of F. So I want to isolate this guy. I'm going to subtract 32 from both sides. It's kind of like step 1 to isolating this, where imagine all this stuff cluttered around C. It's kind of like layers of a present. We want to unwrap from the outside in. So now we have F minus 32 is equal to 9 over 5 times C. Right? So how to deal with fractional coefficients, well, so the coefficient is just a fancy word for saying the factor that you multiply the variable to. We want something that looks like c equals blank eventually, but c is the same thing as 1 times c. So we want to multiply both sides of this equation by something that cancels out the 9 over 5, but leaves 1. So it turns out that that number is 5 over 9, because if we can exactly cancel out the denominators and the numerators, but we have to do it to both sides. So our final answer now becomes c is equal to 5 over 9 f minus 32. We can leave it like this. If you would want, you can distribute the 5 over 9. I personally don't like distributing the 5 over 9 because it gives you a really annoying fraction to work with over here. I'd rather subtract a whole number and then deal with a fraction. Okay, so now let's use our formula. So let's start with 50 degrees f. So we have f is equal to 50, and now c is 5/9 50 minus 32. So if we simplify the inside of the parentheses first, we're going to get 18. And I can cancel out 18 and 9 really well. We're going to get 10 degrees Celsius. Easy. All right. And for the next one, we want to do the same for 5 degrees Celsius. So this one's going to be slightly trickier because we're going to need negative numbers. So now we have 5 minus 32. Well, 5 minus 32, we can think of it as adding 5 and negative 32. These are two numbers of opposite signs. So it's actually telling us, okay, we need to subtract these two first. So this gives us a 27, and we keep the minus sign because of the two summands, 32 has bigger absolute value than 5 does. It's farther away from 0. So the sign of that will win out. And again, we can cancel out really nicely and get minus 15. So we get some nice clean numbers. So for the very last question, I left it kind of as food for thought at the end of class. There's exactly one temperature where the Fahrenheit and Celsius measurements are going to equal each other. So it doesn't matter if I measure in Fahrenheit or Celsius, I'm going to get the same number. So another way of writing this is actually F is equal to C. Okay? I'll let that sink in. So there are two approaches because we have two formulas. We can either solve for F is equal to 9 over 5, F plus 32, or we can solve for F is equal to 5 over 9, F minus 32. These end up being the same thing. Let's just do this one. So actually, I want to move all of my F's to the same side. So I'm going to do that by subtracting 9 over 5F. So originally on this side, we have 1F. And now if we subtract 9 over 5Fs, it's equivalent to subtracting 9 over 5 from 1. This is minus 4 over 5. So we have minus 4 over 5F is equal to 32. And I'll leave the rest up to you. I think the hard part was realizing that you need this. Okay? Awesome. That's it for this class.